Hi folks, welcome back to Physics with Captain Rod. I'm making this video here to help you out with number 19 in your Unit 4 homework. So this is about that problem I mentioned in class, Interstellar is where I got the idea of this problem from, all right? And I think you've already had this exact problem on a different homework set, but I'm going to go ahead and let you work it out again. So the idea is these people are living on the inside of this sphere out in space somewhere where there is no gravity. And then it's rotating. So the idea here is that Timmy's centripetal acceleration is this way, and it's equal to v squared over r. And again, the idea is that as far as Timmy is concerned, he would kind of perceive that as being forced downward. Timmy would perceive that as a downward acceleration. And the idea now is to take this v squared over r and set it equal to 9.8 meter per second to simulate gravity. Now, if you do that, you can get the v without too much trouble at all. You're going to get some number out of that, and that's going to be in meter per second. All right, the next step here, right, because it says, let's see, what rotation rate is needed in radian per second, right? Well, once you have this number in meter per second, speed, remember, is distance over time. And if you use, there we go. My pen's giving me a little trouble here. If you use 2 pi r for the distance and then calculate t, you'd be getting what's called the period, the time to go around once. And then you can calculate the angular velocity just by taking 2 pi and dividing by the t that you just calculated. And that will tell you the angular speed in radians per second to calculate the speed at the the rotation rate needed to simulate gravity. All right, the other question here, and I guess I did not do them in order, but let's see, what angular acceleration can these rocket engines accelerate the craft at? So if we look at this picture, and I put force vectors in for the rockets, okay, so we have a 2,000 Newton force vector produced by this rocket and a 2,000 Newton force vector produced by the second rocket. And that's pretty well it. I can't think of any other forces to add to this. Now notice that the net force is 0, right? But not the net torque. Both of these forces are producing clockwise torque. So what we want to do is write a Newton's second law equation. The sum of all torques equals I alpha. And this thing is accelerating clockwise, so I would just do clockwise positive. There's no reason to introduce a bunch of minus signs. Okay. Then the torque produced by this force, right, is 2,000 times this distance. Same thing goes with the other 2,000 newtons. So that should allow you to calculate the net torque, like what goes under this, no problem at all. Now for the moment of inertia, go back to that table and look up the closest geometry that you see that looks like this object. And that will give you an idea of how to calculate the moment of inertia. So that should get that done for you and get you through that problem. I hope that this helps. Have a great day.